Hello everybody, so today we will be entering chapter 4, which is on magnetism. So this chapter won't be in your exam, but it will be the chapter for your assignment, okay? So in this topic, I think there's 4. There's 7 subtopics, okay? So chapter 4 are the 7 subtopics, but you just need to understand so that you can solve the assignment questions lah. Alright, so the first subtopic is on magnetic field. In this subtopic, you should be able to define what is magnetic field, identify the sources of magnetic field, for example, a bar magnet and a current carrying conductor, the earth magnetic field, and then you have to also to be able to sketch the magnetic field lines lah, okay, for both of this also. Okay, so magnetic field is defined as a region where the magnet will experience a magnetic force. Okay, so for example, a stationary electric charge could be surrounded by an electric field only, but when it moves, it will be surrounded by both electric and magnetic field. Okay, so the motion of the charge causes the production of magnetic field lah. Okay, so if it's stationary, it won't experience any magnetic field. Okay, all right. So the magnetic field has 2 poles, which we call as the north and the south pole. So these poles are always found in pairs, whereas a single magnetic pole has never been found. Nah, kalau kamu jumpa tu mungkin dia patah lah kali. Bukan patah, memang tidak. There's no magnet does not have 2 poles. Okay, so as we all know, like poles will repel each other, whereas opposite poles will attract each other. Okay, so magnetic field lines is used to represent the magnetic field lah. Okay, so by convention, the magnetic field will leaves the north pole and enters the south pole. Okay, so please always remember that when you are trying to draw the magnetic field lines. So from north to south always. Okay, so it can be represented by straight lines or curves lah. The tangent of the curve, which is this one here, indicates the direction of the magnetic field. Okay, so it can also be represented by crosses or by dotted. For example, if you look, this is your paper lah. Okay, paper, and then if the magnetic field is entering this paper, what we will see from above, so this is our eyes, so we would see an X. Okay, so that means the magnetic field lines is entering the page perpendicularly. Okay, so vice versa lah, if you see a dot, it basically means that the magnetic field is leaving the page. Okay, so kamu ka nampak dot di sini. Okay, all right. So a uniform field is represented by parallel lines of force lah. This means that the number of lines passing perpendicularly through this cross-section area are the same. Okay, so a non-uniform electric field pula represented by non-parallel lines, which is macam ni lah. Okay, so the number of electric field will vary at different unit cross-section, as shown here lah. Okay. So the number of lines per unit cross-sectional area, actually I forgot to add B here. Okay, so the number of lines so the number of lines per unit cross-sectional area is proportional to the magnitude of the magnetic field. Okay, so the greater the number of lines, the greater the magnetic field. Okay, so they do not intersect each other lah. Right? Okay, so let's look at the magnetic field lines pattern. If for a compass needles, we can, oh, okay, sorry. The pattern of the magnetic fields can be determined by using a compass needles or sprinkling iron fillings on paper. Okay, so this is your magnet, and as you can see, the compass is pointing to the direction of the south pole lah. So it always goes from the north pole to the south pole. Okay, and then for the second method, we can use iron fillings, which would actually indicate the direction of the magnetic field lines juga lah, ataupun the pattern of the magnetic field lines. Based on this diagram here lah, kita boleh nampak the pattern. Okay, and these are some of the magnets and their magnetic field lines lah. Okay, all right. Okay, now the Earth's magnetic field. So the Earth's magnetic field is like a giant bar magnet, as we can see here. Okay, so the with a pole near each. Oh, sorry. Okay, so since we say that this is the magnetic field for the Earth is like a giant bar magnet. Okay, so we have geographically the north is gonna be here, the south is gonna be here. This is their geographic pole. However, remember, if it is the Earth's magnetic field, it will be the other way around lah, sebab the south pole will be attracted to the north pole here, which is the true north, and then the south pole here will be attracted to the north pole of the magnetic field on Earth lah. Okay, so okay, I explained that one. So the figure also showed that the field lines are essentially horizontal, which is basically parallel to the Earth's surface lah. Okay, what you have to know for this one is basically the magnetic field for Earth is like a giant bar magnet lah. Okay, so kamu tengok the true north is here, but the magnetic field south pole will be here lah. Itu je lah yang you have to understand. Okay, alright. Now, magnetization of a soft iron. Okay, so how do we magnetize a soft iron? Okay, so we can either use a permanent magnet ataupun using electrical circuit. Okay, so untuk use a permanent magnet, we can either use one permanent magnet atau two permanent magnet. Okay, so a permanent magnet can be brought near to the soft iron, which is this one here, and touch the surface of the soft iron. And then this method, what we are doing here, is known as induced magnetization. We are inducing magnetization lah. Okay, so the arrow is representing the magnetization direction, and the arrowhead is the north pole, whilst the arrow tail is the south pole lah. Okay, so it is also known as domains, which is tiny magnetized region because of the spin magnetic moment of the electron lah. Okay, so in an unmagnetized piece of iron, the domains are arranged randomly, but it is aligned in one direction. Okay, it will be aligned when the soft iron becomes magnetized, which is this one lah, derang panggil tu domains. Okay, so the soft iron will become a temporary magnet where its south pole will face the north pole of the magnet and vice versa lah. Okay, so that is induced magnetization for using a permanent magnet, one permanent magnet. Okay, untuk guna two permanent magnet pula, do the same thing, and it would gives us the same result lah. Okay, alright. Now sorry, the domain maksud dia ni yang arrow niya. So this is north, this is the south pole. Okay. Alright, now second method, using the electrical circuit. So place a soft iron inside the solenoid, and it should be connected to the power supply lah. Okay, so when the switch is closed, meaning the circuit is turned on, it produces a magnetic field lah. So the direction of the field can be found by viewing the current from both ends. Okay, so we view from both end of this solenoid by using the right hand grip rule. Okay, so for example, let's look at this one. So you are using the right hand grip rule lah. Okay, so the thumb would be facing our north pole, and the other fingers shows us the direction of the current in the solenoid. Okay, boleh faham yang itu. This one is the same. What else? Just make sure you look at the wire punya drawing lah. Okay, so this one wire dia terus begitu, so the current should be going down. But this one, even though the current is pointing downwards, the current flows back up. Let me check. Oh, okay, so the current goes from here, meaning that the current's gonna go up from here. Okay, what you need to know is you need to use right hand grip rule kalau ada soft iron in a solenoid. Okay, so these are some of the, if you drop a permanent magnet or strike it with a hammer, so we can you could jar the domains into randomness. Okay, so instead of this being aligned in one direction, the magnet would be the domains would be pointing in all directions, so random lah. Okay, so due to that, it can lose some or all of its magnetism lah. Okay, so heating a magnet pun could cause to the magnet to lose its magnetism. And permanent magnet pula can be demagnetized by placing it inside the solenoid connected to an alternating source. Okay, so that is when you want to demagnetize a permanent magnet lah. Okay, alright. Okay, so magnetic flux density, which is B. It is defined as the magnetic flux per unit area across an area at right angles to the magnetic field. Okay, so this is, I forgot the term, but this is magnetic flux, and this is the area perpendicular to the magnetic field lah. Okay, so it is known as magnetic induction, also known as magnetic induction lah. Magnetic induction. Okay, ataupun magnetic field intensity ataupun strength. Okay, so it is a vector quantity and its direction follows the direction of the magnetic field. So the unit is Tesla or Weber per meter square. Okay, so 1 Tesla is equal to 1 Weber per meter square, also equal to 10 to the power of 4 Gauss. Okay, alright, so that is on our first subtopic.